Hey everyone, ready for another deep dive?
Always ready to explore.
Well, today we're going to tackle something pretty massive, literally, the elements.
Ah, the building blocks of the universe.
Exactly. And to guide us, we've got this incredible book called H.E. H.E. Fair.
I love that title. It captures the essence of the elements so well, their long history and how they make up, well, everything.
Right. I mean, we interact with elements every day, but do we ever stop to think about, like, where they came from?
Yeah, it's easy to take them for granted, but every element has this epic backstory stretching back billions of years to the very beginning.
Okay, so let's rewind all the way back. Talk to me about the Big Bang. How does this massive explosion fit into the story of elements?
Picture this, the universe in its earliest moments. It's this super hot, incredibly dense soup of energy.
Hotter than my coffee on a Monday morning.
Way hotter. And as the universe expands, it starts to cool down, that energy. It starts to become matter. And the very first elements, hydrogen and helium, pop onto the scene.
So hydrogen and helium,
Yeah.
two of the lightest elements. They're the universe's like starting ingredients.
That's right, the original recipe. But it gets even wilder. Everything else, all those heavier elements, the carbon in our bodies, the silicon in our phones, all came from stars.
Wait, hold on. Are you telling me that the iron in my blood was once part of a star?
Absolutely. Think of stars as these giant cosmic furnaces.
Mm-hmm.
Deep down in their cores, under insane pressure and heat, hydrogen atoms fuse to form helium. That's the process that makes stars shine.
So stars are basically just giant fusion reactors.
Pretty much. And as they get older, they keep fusing, creating heavier and heavier elements. Carbon, oxygen, nitrogen, even iron. It's like they're building up the periodic table step by step.
Whoa, so stars are element factories? Pumping out the building blocks of, well, everything.
It's pretty incredible, isn't it? But hold on, the story doesn't end there. When massive stars reach the end of their life, they explode.
Oh, right. Supernovae.
Exactly. And during a supernova, it gets so hot and the pressure is so intense that even heavier elements are created. Gold, platinum, uranium, elements that wouldn't exist otherwise.
Whoa, so supernovae are like these grand finales, scattering these newly made elements across the universe.
And eventually that stardust clumps together, forming new stars and planetary systems, and the cycle continues.
So all the elements we see, even the ones that make us, they were all forged in the hearts of stars, scattered across the universe by these epic supernovae.
It's pretty humbling, isn't it?
It definitely makes you feel connected to something much bigger. Okay, so we've gone from Big Bang to supernova. It's a wild ride just to get the ingredients for our planet. But I'm curious, before telescopes and all that fancy equipment, how did ancient civilizations even try to figure out what things were made of?
That's a great question. It's amazing to look back and see how early civilizations tried to make sense of the world around them. They didn't have labs or microscopes, so they relied on observation and thought experiments.
So like just looking at stuff and thinking really hard about it.
Pretty much. Take the ancient Greek philosophers, for example. They came up with this idea that everything was made of four basic elements: earth, water, air, and fire.
Makes sense, right? You look around, and that's basically what you see.
It's a pretty intuitive idea. Of course, we know now it's not quite accurate, but it was a huge step towards trying to understand the building blocks of the world. They were looking for patterns in nature, trying to figure out how it all fit together.
Like a giant puzzle.
Exactly. And even though their theory wasn't perfect, it laid the foundation for a more scientific study of matter later on.
Okay, so we've got philosophers thinking about elements.
Right.
When did things start shifting toward, like, actual science?
It was a gradual process, with lots of brilliant minds adding to the story. But a major turning point was the 18th century, during the Age of Enlightenment. There was this guy, Antoine Lavoisier, a French chemist. He totally revolutionized our understanding of combustion.
Oh, Lavoisier.
No?
Didn't he, like, debunk that whole phlogiston theory?
Yeah.
I love that story in school.
Yeah, you got it. Phlogiston was this idea that people had about how things burned, but it was totally wrong. Lavoisier was super meticulous with his experiments, and he proved that oxygen was the key to combustion. It was a big deal.
Okay, so we understand how things burn. How does that link back to elements?
Well, Lavoisier's work led to identifying oxygen as an element, and it showed how important it was to be really careful and observant in chemistry.
So thanks to Lavoisier and his buddies, we're starting to move away from just thinking about elements to actually studying them scientifically. But how did we get from there to the periodic table, that chart that organizes all the known elements.
Ah, yes, the periodic table. That's where Dmitry Mendeleev comes in. This brilliant Russian chemist published his periodic table in 1869. It was groundbreaking. He organized all the elements based on their properties, and get this, he even left gaps in his table.
Gaps? Why would he do that?
He was predicting the existence of elements that hadn't been discovered yet. Based on the patterns he saw, he knew there were elements missing.
Whoa, that's some next-level scientific intuition.
Right, and the amazing thing is, he was right. Over time, scientists found those missing elements, and they fit perfectly into the gaps Mendeleev left.
Okay, so the periodic table isn't just a list. It's like a map of the elements and how they relate to each other.
Exactly. It's this incredibly powerful tool that helps us understand the patterns and connections between elements. And it all started with Mendeleev's brilliant mind.
All right, so we've gone from the Big Bang to the periodic table, and it's clear that the world of elements is incredibly diverse. We've got shiny, bendy metals, brittle nonmetals, and those in-betweeners, the metalloids. But what makes them so different? What's happening at the atomic level that gives them such distinct personalities?
Well, that's where we get into the fascinating world of atoms, with their protons, neutrons, and those tiny but mighty electrons.
All right, I'm ready to go even deeper. Tell me about those electrons.
Let's do it. So imagine electrons like planets orbiting the sun, or in this case, the atom's nucleus. The farther away a planet is from the sun, right, the more energy it has.
Okay, I'm picturing it. So electrons in those outer shells, they're kind of like the high-energy folks in the atom.
Exactly. They're the ones that are more likely to interact with other atoms, forming bonds and creating all sorts of interesting compounds.
So those outer electrons, the valence electrons, they're the social butterflies, making all the connections.
You got it. And the number of those valence electrons, well, that determines an element's personality, like how it bonds with other elements, what kind of compounds it forms, all that jazz.
Okay, so valence electrons are key. Now, how do we classify elements? We've got those big categories, right? Metals, nonmetals, and those in-betweeners, the metalloids.
You got it. It's like the periodic table's version of rock, paper, scissors.
Haha, I love that analogy. All right, so metals. They're the shiny, bendy ones, right?
Yep. Think of copper wiring or aluminum foil. Metals are great conductors of heat and electricity.
And they're always ready to give up those outer electrons, right, to become positive ions.
You're on a roll. Now, on the flip side, we've got nonmetals. They're more likely to, hoard those electrons, becoming negative ions. They're often dull, brittle, and not good conductors.
Okay, so metals are givers and nonmetals are takers.
Exactly. And then we've got those metalloids hanging out in between.
The wild cards, like silicon, right? It can be a conductor or an insulator, making it perfect for computer chips and all our gadgets.
Silicon is a rock star. Totally revolutionized the digital age.
Right. Okay, but within these big categories, there are some even more specialized groups of elements. What about those rare earth elements we talked about earlier?
Ah, yes. Rare earth elements. They might sound obscure, but they're crucial for a ton of modern technologies. Everything from smartphones and electric cars to renewable energy systems.
I remember hearing they're super important for making powerful magnets and lasers.
You got it. And they're special because of their unique electronic configurations. Their inner electron shells are only partially filled, which gives them some pretty cool magnetic and optical properties.
So even though they're called rare earths, it's not that they're super scarce on Earth.
Right. It's more about finding them in concentrated deposits that make them worthwhile to mine. It's like finding a needle in a haystack. And because they're so important for technology, there's a lot of global interest in who controls those supplies.
Makes sense. Okay, what about those transition metals? You mentioned they were kind of like the chameleons of the periodic table.
Yeah. Transition metals have this ability to exist in multiple oxidation states. Basically, they can gain or lose electrons pretty easily, which makes them super versatile in chemical reactions.
So they're adaptable, changing roles depending on the situation.
Exactly. And this flexibility makes them super useful. They're often used as catalysts, speeding up chemical reactions without getting used up in the process.
Oh, right, like platinum and catalytic converters, helping reduce pollution from cars?
Yep, and iron and hemoglobin carrying oxygen throughout our bodies.
So these transition metals are like the behind-the-scenes heroes, quietly making things happen in both the industrial world and the natural world.
That's a great way to put it. Now, let's zoom in on the periodic table itself. It's not just a random chart. It's a carefully structured map that reveals all sorts of connections between the elements.
The periodic table. I've always been fascinated by it. It's like a giant puzzle where all the pieces fit perfectly. How is it organized? What secrets does it reveal?
Well, the periodic table is arranged by increasing atomic number. So basically, the number of protons in an atom's nucleus. But what's really cool is how it groups elements with similar properties together.
Okay, so it's not just a list, it's a way of visually representing how elements relate to each other.
Right. And elements are arranged in vertical columns, called groups or families. Elements in the same group tend to have similar chemical properties because they have the same number of valence electrons.
Those outer electrons are calling the shots, so their location on the periodic table basically tells us a lot about how they'll behave. What are some of those groups and what makes them unique?
Okay, so let's take the alkali metals. They're in group 1, and they include elements like lithium, sodium, potassium. They're all super reactive metals, like they're eager to give up that one valence electron.
So reactive they could explode if you drop them in water.
Pretty much. Now, compare that to the noble gases all the way over in group 18. These guys, helium, neon, argon, they're known for being super chill, non-reactive.
So they're like the introverts of the periodic table.
You got it. They've got a full outer shell of electrons, so they're happy and stable on their own. That's why they used to be called inert gases, because they don't like to react with anyone.
Okay, so groups are the vertical columns. What about those horizontal rows?
Those are called periods, and they represent how electron shells are filled as you move across the table. Each period is like a new energy level for those electrons.
Okay, so it's not just about how many electrons an element has, but also where they're located and their energy levels.
Exactly. And as you move across a period, you see a gradual shift in properties from metals on the left to non-metals on the right.
The periodic table is mind-blowing. It's like a cheat sheet for understanding the entire world of chemistry.
It is. It's a testament to Mendeleev's brilliance, how he organized it all. And to think he even left gaps for those undiscovered elements.
It's amazing how much we can learn just by looking at patterns and applying logic.
Right. The periodic table is one of those iconic symbols of science, and chemists still rely on it today.
Okay, we've covered a lot, from electron configurations to how the periodic table is organized to the unique properties of different groups of elements. But how does all this theoretical knowledge translate into real-world applications? How have humans interacted with these elements throughout history, and how do we harness their power today?
That's where things get really interesting, because our relationship with elements has literally shaped our history, our technology, and even our existence.
Okay, I'm ready for a history lesson, element style.
All right, let's rewind the clock and take a journey through time, exploring how humans have used elements, from the simplest tools to the most cutting-edge technologies. It's a story filled with ingenuity and a constant drive to push the boundaries of what's possible.
Okay, I'm ready. Take me back to the beginning. How did ancient civilizations first interact with these building blocks of matter?
Well, imagine a time before written language, before the wheel, even before agriculture. In this world, discovering and using elements wasn't just about convenience or progress, it was about survival.
So we're talking about a time when even the simplest tools were a major technological leap forward.
Exactly. Imagine those first humans who figured out how to chip flint to make sharp edges, how to control fire. Those were monumental discoveries.
Those early interactions with elements really laid the foundation for everything that followed.
Absolutely. And as human knowledge grew, so did our ability to work with elements. Take copper, for example. It's found naturally, and you can shape it into tools and ornaments.
Right. Copper was a huge step up from stone tools.
Oh yeah, a game changer. Copper tools were sharper, more durable, and could be used for all sorts of things. And then came smelting, figuring out how to extract metals from their ores. That opened up a whole new world.
Smelting, it's like the original life hack, turning something ordinary into something extraordinary.
I like that. And that led to the creation of alloys like bronze, combining copper and tin to make something even stronger and more durable than either metal on its own.
Ah, the Bronze Age. More sophisticated tools, weapons, and those incredible bronze statues and artwork.
Exactly. Bronze was a big deal for a lot of civilizations. From ancient Egypt to ancient China, it helped shape societies and empires.
It's amazing how discovering and learning to manipulate copper, tin, and then bronze has such a huge impact on human history.
It really shows how our relationship with elements has driven so much progress. But as societies grew and their needs got more complex, the search for even better materials continued. And that's where iron comes in.
The Iron Age. This is when things really took off. Iron tools, iron weapons, iron for everything.
You got it. Iron was tougher to work with than bronze, but it was super strong and there was a lot more of it, so it was a game changer.
I can picture those blacksmiths sweating over hot forges, hammering out iron tools and weapons that would change the course of history.
It revolutionized everything: agriculture, warfare, even art. Iron tools helped build bigger structures and shape the landscapes of entire civilizations.
It's incredible how iron, this one element, had such a huge impact on human history.
It really is. And as our understanding of chemistry got better, we got better at isolating and manipulating elements. The 18th and 19th centuries saw tons of new elements discovered, all thanks to those advances in chemistry and lab techniques.
Right. This is where those scientific heavyweights like Lavoisier and Mendeleev come in. They totally changed how we understood elements and how they were connected.
Exactly. Lavoisier's experiments laid the groundwork for modern chemistry. And Mendeleev's periodic table gave us this framework for understanding the relationships between elements and even predicting their properties. These were huge breakthroughs in figuring out how matter works.
And then came the Industrial Revolution. That must have been a turning point in our relationship with elements.
Absolutely. The Industrial Revolution created this huge demand for raw materials. We needed coal to power those steam engines, iron to build railroads and factories. It was a whole new era of technological advancement, and elements were at the heart of it.
It's like we went from shaping elements into tools and weapons to using them to power entire industries and reshape the planet itself.
You got it. And with that power came a new awareness of how we were impacting the environment. We started realizing that we had a responsibility to use elements wisely.
It's a reminder that every technological leap has its consequences. Okay, so how did our relationship with elements keep evolving in the 20th century?
The 20th century was all about pushing boundaries. Advances in physics let us explore the atom even deeper. That's how we discovered radioactivity, which led to nuclear energy, both its potential as a clean energy source and, unfortunately, its potential for destruction. We even started creating new elements, adding to the periodic table and our understanding of matter.
Wow, so we unlocked a whole new level of power, but also a new level of responsibility.
Exactly. We realized that our discoveries could be used for good or for harm. It's a legacy that we're still grappling with today.
It's a complex story, that's for sure. So as we move further into the 21st century, how do you see our relationship with elements evolving?
I think we're entering an era of incredible innovation and exploration. Fields like nanotechnology, material science, and the quest for sustainable technologies, they're all pushing the boundaries of what's possible with elements.
It's exciting to think about the possibilities, but it's also a bit daunting given the challenges we face, like climate change and resource depletion.
Yeah, the stakes are higher than ever. But I believe that by understanding the elements, their properties, and how they interact, we can find solutions to some of the biggest problems facing the world.
This deep dive has been an incredible journey. We've gone from the Big Bang to the periodic table to the Industrial Revolution and beyond. It's given me a new appreciation for how interconnected everything is, from the stars to the very ground we walk on.
It's been a pleasure exploring this fascinating world with you. And remember, the story of the elements is also the story of ourselves.
Well said. And on that note, we're going to wrap up this deep dive. I hope you've enjoyed learning about the amazing world of elements. Until next time, keep questioning, keep exploring, and keep being curious about the universe. Okay, so we've journeyed from the Big Bang to the hearts of stars, right? We've seen how elements were born and made this epic journey to Earth.
Yeah, it's mind-blowing.
Totally. But now let's zoom in, on how humans have actually interacted with these building blocks.
Right, how we shaped them into tools and technologies, and basically how we've built our entire civilization.
Exactly. So let's start at the beginning when, even the simplest tools were major breakthroughs for early humans.
Imagine a world where the sharpest edge came from a chipped piece of flint, or warmth came from, a carefully crafted fire.
Yeah, and then imagine discovering gold or copper. I bet it felt like magic, realizing you could shape these materials.
Totally. It must have been incredible to discover those naturally occurring elements and see how you could work with them.
It's like those early humans were writing the first chapters of human ingenuity with elements.
Yeah, through trial and error, they learned to shape these materials into tools, weapons, even early forms of currency.
And each new discovery opened up more possibilities.
Right. It fueled their creativity. So it's like this chain reaction of innovation with each new element leading to new technologies.
What were some of those major turning points in our relationship with elements?
Well, discovering smelting was a huge one. Imagine that aha moment when someone realized, hey, we can actually extract metals from their ores.
Melting. It's like the original life hack.
Haha. I love that. And it totally changed the game. Suddenly, we weren't limited to just those naturally occurring metals. We could create alloys with even better properties.
Like bronze, right? A mix of copper and tin that was a staple for so many ancient civilizations.
Exactly. Bronze was strong, durable, versatile. It ushered in a whole new era of advancement for technology and even culture.
The Bronze Age. We see those awesome bronze statues and artwork from ancient Egypt, ancient China.
Exactly. Bronze played a key role in shaping those societies and empires. So we go from stone to copper to bronze.
Each step like building on the last. It's like climbing a technological ladder, each rung taking us higher.
And then about 3,000 years ago, we enter the Iron Age.
The Iron Age. I picture those blacksmiths, sweating over hot forges, hammering out iron tools and weapons. It's iconic.
It was a total game changer. Even though iron was tougher to work with than bronze, it was way stronger, and there was so much more of it.
Yeah, it revolutionized agriculture, warfare, everything.
Exactly. Iron tools helped build bigger structures, too, shaping the landscape of civilizations. So as our knowledge and technology advanced, we got even better at working with elements.
Right, the 18th and 19th century saw a boom in new element discoveries.
Yeah. Think about Lavoisier and Mendeleev, those giants of science. They really transformed how we understood elements and how they were connected.
Lavoisier's experiments laid the foundation for modern chemistry.
And Mendeleev's periodic table gave us this framework for understanding those relationships between elements and even predicting their properties. It was huge.
Then came the Industrial Revolution. Things really kicked into overdrive then.
Absolutely. The demand for raw materials exploded. We needed coal to power those steam engines, iron to build railroads and factories.
We went from shaping elements into tools to using them to power entire industries.
And to reshape the planet itself, it was incredible, but it also made us start thinking about the environmental impacts.
We started to realize that with this power over elements comes responsibility.
Exactly. Okay, so fast forward to the 20th century. What happens then?
Another era of huge breakthroughs.
Yeah.
Right, we went even deeper into the atom.
Yeah, advances in physics let us unlock the secrets of radioactivity, which led to nuclear energy.
The promise of clean energy, but also the threat of these devastating weapons. It's a lot to grapple with.
It really is. And then we even started creating new elements ourselves, adding to the periodic table in our understanding of matter.
It's incredible how far we've come.
Yeah.
So as we move further into the 21st century, where do you see our relationship with elements heading?
I think we're on the verge of a whole new era of innovation and exploration. Nanotechnology, materials, science, the push for sustainable technologies. They're all pushing the boundaries of what we can do with elements.
It's exciting, but also a little daunting given all the challenges we face.
You're right. The stakes are high. But I think our understanding of elements and how they work will be key to solving some of the biggest problems in the world.
This deep dive has been an incredible journey, from the Big Bang to the periodic table to the Industrial Revolution and beyond. It's given me a whole new perspective on the elements and their role in shaping our world.
It's been a pleasure exploring this amazing world with you. And remember, the story of the elements is really the story of us.
Well said. All right, folks, that's a wrap on this deep dive into the world of elements. We hope you enjoyed it. Keep those minds curious and keep exploring the universe, because there's always something new to discover.